What we're going to talk about in our session here, folks, is we're going to talk about how do we actually measure the performance of a tractor. And the only true measure is PTO, rated PTO horsepower, or rated draw bar. We're going to look at PTO today. We're going to take the theoretical that you saw over in the other 10 and convert it here to a practical. In other words, Dave told you about the improvements. We're going to demonstrate the improvements by actually measuring the rated PTO horsepower on the tractor. We're going to then look at if we have a good, very good, strong torque curve, how can we employ that for fuel savings and improve efficiency? And our whole story in this tent right here is going to revolve around the fact that torque is king when it comes to an agricultural tractor. Okay? Torque is the rotational force. Torque is the crankshaft terminal. Torque is the transmission input shaft and output shaft terminal. Torque is the PTO shaft terminal. All we can do is measure torque. Everyone talks about horsepower. Horsepower is torque times the RPM of the shaft divided by 5250. So you actually do a mathematical computation to get horsepower. You really measure torque. Okay? Torque is measured in resistance, pound-feet, or as we call it in the States, mostly foot-pounds, but it measures the amount of force in a rotational body. Okay? All right. How do we measure it? This thing right here, it's called the dynamometer. It's what you see out here attached to the tractors. A dynamometer measures rotational force or torque, right? And it does that by the shaft here is attached to the tractor PTO and it's turning. That shaft is attached to a drum inside the dynamometer that's spinning. Inside that drum are brake shoes that I control with a hydraulic actuator, and the drum is trying to turn. The brake shoes are stationary and they're connected to this torque beam on the back. So as I apply more resistance to the drum, it tries to slow down. It transfers that force into the torque beam, the load cell, and we'll see our display come up here on our screen as horsepower, torque rise, and other measurements. So it's real time. It's actual. You can't fake it. It's colorblind. Doesn't matter what color piece of equipment's attached to it. It's going to give us the actual readings off of it. We measure torque, and from that, the electronics in there will display horsepower as a function of that formula there. Okay? Make sense? Next one, Jim. What we're looking at here are all the models across the various manufacturers, the OEMs, but they all have different model numbers. Very confusing, can be. What we can drive it back to is rated PTO horsepower. All these tractors, regardless of their model number, all should be able to produce 205 PT horsepower on that dyno at a rated speed. Rated means a defined engine or PTO shaft speed. If you don't have that rated number, as we'll show you here, you can pick any number on your horsepower chart. It's kind of meaningless. I need to know what our competition, what their rated speed is and what their PTO horsepower is, and then I can compare our tractor to their tractor equally across the field. Does that make a degree of sense? Yeah. So it's the standard. Years back, this is how everything was measured. Today, we have other ways that we discuss it, but we're going to take it back to the most simple format and discuss rated PTO horsepower. We're going to be working on a tractor out here that is a T8 350, thank you. T8 350. So we're going to run the dyno on. If you would please, look on your chart and tell me what the rated PTO horsepower is of a T8 350.
235.
235, exactly. T8 350, 235. And the rated speed is 2,000 engine RPM. Okay. So now we have the rated speed. We know the PTO horsepower, so we can put it on that dynamometer and we can measure to see if you're getting 235, you're getting less, you're getting more, right? That's the standard that we want to be able to measure all agricultural tractors equally by measuring PTO horsepower at a rated speed, okay? What we're going to do next is we're going to switch over to the dynamometer, and we're going to, this is a screen that you see as we actually make our runs. We're going to take the tractor, we're going to start it out. You'll be able to look at PTO input shaft speed. That's the PTO speed, okay? So when we get to 1117, we're going to look at the horsepower rating right here, and we're going to see if it's 235, 252, 218, whatever. We'll be able to capture that at that point in time. And then we'll be looking at our torque and our torque rise, and when we're finished with the run, we'll be able to look at the white line, which is our horsepower graph, and we'll be able to look at our red line, that's our torque graph, okay? We'll be able to compare the two. Now, before we run the dyno, I just want to show you a brief little video here that explains why we emphasize torque over horsepower units. And here you have a steam engine that's rated at 18 horsepower, and you have a tractor back here, and by the way, it doesn't matter what color that tractor is, the result's going to be the same, 400 plus horsepower. Now, we said horsepower is torque times RPM. That's the flywheel, the speed at which that steamer is turning over. It's like you can count the spokes, right? So it doesn't have any RPM, but it's got cylinders on it like this, so it's got tremendous torque. What do you think's going to win here, guys? Well, 18 horsepower versus 400 plus horsepower. Torque. That's why torque is king. Torque is what makes that tractor pull the attachment through the ground, break the hard pan. Torque will always win over horsepower. So when you think about an ag tractor, disregard the horsepower numbers. You want to look at torque, and you want to look at the torque curve, okay? And that's what we're going to demonstrate to you here in a couple seconds. So my cohort, Mr. Day, is going to come up here. I'm going to crank the dyno. Jim's going to walk you through the charts, and we're going to make some noise and smoke here, and hopefully we'll get to see what a good tractor looks like.
Okay, a couple things to go over that Randy was talking about. Number one, to keep in mind, what we're measuring on the dynamometer is PTO RPMs. 2,000 engine RPM is our rated speed. 2,000 engine RPM equates to 1117 on our PTO. So what we're looking for here is 1117 on our PTO speed. What you're seeing here is the previous curves that we ran. This is a live feed from our engine dynamometer, our PTO dynamometer. What we're going to do when Randy gets the dynamometer ready, we're going to click the start button, and we're actually going to watch these graphs get built. One thing that's happened with dynamometers is no different than ag tractors today. We still have transmissions, we still have engines, there's been some advances, but a lot of the advances are in electronics. Dynamometers are a whole lot different. All the data that we used to have to collect and put on graph paper and make curves, now we have the ability to collect all this data real time, automatically plot it. So what you'll see is you've got torque on the right, you've got PTO RPM on the bottom, and power over on the left. As we run this curve, you'll see this graph actually scale itself as we run across from 1200 PTO RPM down to about 700 PTO RPM. So anybody have any questions before we go ahead and get started, or what you're looking at, or what we're going to try to find here? Okay. Started a new curve, 1195 to 1235. So you're only talking about 40 RPMs. So you're seeing every little RPM jump as Randy applies that brake that he talked about to the engine, tries to actually stop the PTO. We're going to lug the engine down. You see your PTO RPMs here. We'll measure we can't measure horsepower directly. We have to measure the torque to calculate horsepower. Dynamometer is automatically calculating our horsepower. We're looking for 1117, right? That's our rated. Again, it goes back to rated engine speed, 251 and 1184. Now the key that we're looking at, white is our horsepower, red is our torque. we said rated number at 1117, 251. What was our PTO horsepower of that T8 350? 235. So new tractor's got about 60 hours on it. We've been here for 2 weeks. That thing's increased 12 horsepower since we've been here. Engines like to be lugged. They like to be worked in hard. That thing's increased 12 horsepower. Second thing we're looking for is that where those two lines cross. In this industry, it's basically called, we're looking for the sweet spot, where the horsepower curve and the torque curve cross. I'm going to go back and shut this run off. That Randy's going to grab it for me. What we just did was end our run. White is horsepower, red is torque. Where those two lines cross is affectionately referred to in the industry as sweet spot, where torque and horsepower cross. What that is where you want to operate that engine. It's the maximum efficiency of that engine. So when Vic showed his class this morning and Nathan showed his class referring to ground speed management, that's where the tractor tries to set itself to a specific spot. We generally want to operate right in that range. About 900 on the PTO. It's about 1725 on our engine speed. The key that we're looking for, we went back to the term torque is king. Our number one issue right there is torque. If I tell the electronics in that tractor that I want to operate right there and I set my ground speed right at that point, my torque curve doesn't hold nice and flat like that, kind of noses off, that tractor's not going to be able to hold its RPM, it's not going to be able to maintain, it's going to have to shift, constantly working the transmission up and down. If I have a nice, smooth, flat curve like that, the torque continues to rise or stay flat, now the tractor can manage itself. I have torque is reserved in the engine. It can maintain that, so now I've got ground speed management in my tractor. I have the ability to let the electronics take over and operate it because of that torque curve. Ready to get the data display for me? Next thing we're going to do, we grab our 1117. If you just grab me the max horsepower and max torque, we talked about the technology of the dynamometers. Every 2 seconds we're pulling data out of that dynamo. I can set that to whenever I want. Bottom line is every 2 seconds we're pulling data. That's what's building that graph for me.
252 in horsepower.
Yep, 252.
1188 on torque at rated speed.
Now what are my max?
Max horsepower is like 293. And max torque is going to be down here at 1697.
Okay, so we're quickly going to go through our graphs. If you hit the power graph, we talked about our, again, going back to rating. 1117, 250, what do we get? 252. If I don't refer to the term rated, I can pull a horsepower anywhere on that curve that I want. So in the industry, we've got to get back to the way it used to be, forgetting the hood numbers, and going back to what it was, but rated PTO speed. Now we know every tractor's being compared apples to apples. We're not just pulling numbers off the curve wherever we feel like pulling it. Our torque graph. Okay, this is what we're looking for. In today's industry, every manufacturer has the same challenge. I'm going to let the electronics of the tractor drive itself. I need to have a nice flat torque curve. If the tractor doesn't have a nice flat torque curve, it's not going to have the reserve to be able to maintain itself. When I get a slug, the forage goes through, or when I get into a tough spot in the field, that torque curve drops off, my tractor's going to go down, it's going to have to shift down, and I'm going to start to slip. Whereas here, I've got good solid reserve, I got a nice flat torque curve, the tractor can manage itself to its maximum efficiency. And the last curve is called the torque rise curve. Again, going back to that rated number. 1117, Randy hit a button on the dyno that says I'm at 100% torque because that's my rated speed. The percentage of increased torque above rated is my percentage of increase. About 43% torque rise on that engine. Real good torque rise. But again, always referring back to torque rise above rated. If we don't use the term rated, I can push that button wherever I want and make that number go up or down. Once again, going back to that rated number. Anybody have any questions on torque curves, horsepower curves, or torque rise curves? What you saw, what you didn't see? Okay, the next thing we're going to do, Randy's going to switch us back over to the meter display. We're going to do 2 quick runs for fuel efficiency. And for years in the industry, you've heard the term gear up and throttle back, try to get more efficiency. Well, it still holds true today. Now the advantage we have is the tractors can do it automatically for us. We used to have a skilled operator who would know where he had to put what gear he had to be in, or how to set the tractor. Now the tractor will manage that for us. So what we're going to do is we're going to go through a series of runs, 2,000 RPMs, and we're going to measure it at 150, 175, and 200. So I'm going to grab the fuel numbers over here. At 150, we're going to pull the fuel per hour, and we're going to compare how does that really work? How does gear up, throttle back really save someone money? So 8.4 gallons per hour at 150. The key to this exercise is listen to the engine. 2,000 RPMs. We're at 150. Do we hear the engine drop at all? Have you heard the engine lug down? 175. 9.9 gallons per hour. Engine RPMs. So we're going to run through the same series of horsepower loads and take the fuel numbers and see if we have any fuel savings running that engine at 500 RPMs lower. I think we probably all will agree we're going to see a lower number. The key is what happens to the engine. Will the engine die off? Will it slug off? Will I be able to hold that torque curve that we talked about before? Not to ruin the suspense, but you won't hear the engine lug off. It's going to stay nice. It's going to stay nice and flat. The engine has the torque curve. We've shown that. One of the things is we're trying to show our people and our dealers is that the tractor has the ability to manage that for you. So years ago you had to train somebody how to listen to that, how to gear up, throttle back. Now with ground speed management, you can let the tractor take over for you, and it will automatically give you those efficiencies. It's 150, 75, 9.1. Now we're up to about 0.8 gallons per hour. Again, look at their engine RPMs. We've only dropped 20 engine RPMs. We're putting a 200 horsepower load, 10.2. Basically, at 200 horsepower, we're saving about a gallon an hour. Now, the next thing we're going to do is run that engine down to about 250. We're going to go 35 above the rated PTO horsepower on that engine. He's actually going even deeper. He's going to about 260. We don't hear the engine drop. We're at 1,500 engine RPM. We've only dropped 40 engine RPMs. And from the ear, which is how most people try to drive a tractor, can't even tell that tractor. You never know that tractor is running at 25 horsepower above rated right now. It's actually lugging it that much. But that engine holds nice and steady. Again, confirming torque curving that engine can maintain that ground speed that you've set the tractor to. It's not going to drop off. It's not going to nose off. And you can utilize those electronics and the efficiencies that are in the engine. The key to this exercise for everything we've done here is that we did everything right here. With that tractor, that dyno, the farmer's fuel, in this field, all the data that we made to present our presentation or to create this presentation was done here. So that a dealer has the ability to do this for a farmer, the capability, the technology, the tractors, the dynamometers is there, but it is real world. It's not in engineering, it's not in a lab somewhere. This is real world information. With that, I'm going to have Randy come up and wrap this up and kind of tie all this good information back to real dollars. What matters to a farmer? How much more money did I end up with my pocket at the end of the day? Torque's nice, all that stuff's nice, but what does it mean in real dollars? Thank you, folks.
Okay, you saw that our little experiment here was, number one, the tractor's rated at 235. We're getting 252, so under promise, over deliver. It's always easier to sell that way. Max horsepower is 293, but at rated speed, remember we always go back to rated speed because that's the standard. Down here under fuel economy, by simply taking the engine and dropping it from 2,000 RPM to 1,500 RPM, we saved about a gallon an hour of fuel. That's okay. If I run the tractor 10 hours a day, that's right. 10 gallons, $4, that's $40. That's not the real story. The story is, and the torque backup that Jim showed, and when we ran the dynos, if you have that kind of torque backup, now you can set your ground speed management. And that field out there that used to take 10 hours a day now takes 9 because your slip's under control. The engine's running at maximum, you've got maximum performance. So I've taken an hour out, that's 16 gallons an hour plus 9 more, 25 times 4, that's $100 a day. X number of days you run the tractor, pretty soon you've got a payment made or two. So that's the efficiency that the tractor can produce. That's the value that you want to sell to the customer. Our tractor is more efficient, it's more productive, it saves fuel, therefore in the lifetime of the tractor, the value of this will pay for itself obviously, but it's a lot of value. Because the torque curve will allow you to run at lower engine speed, not 15 but 1800, you know, that's less RPMs every minute. That means your service intervals are extended out, the wear and tear on the equipment is less. All good things happen with being able to throttle back and gear up. Okay, and this torque curve ties just perfectly in with the CVT transmission and the ground speed management features, because quite frankly what you have now is an engine that can pull you through tough spots, and you have a system on the tractor that allows you to adjust it, get it set, and you can put anybody in there to drive it, and they will have maximum efficiency and maximum productivity. So that's really the whole story. The engine is a starting point. You have good torque backup. You have the CVT transmission and the power shift to be able to manage that for maximum efficiency. You're going through the other classes where you can set headland management and also slip factor. So if you've got an engine that can lug like that, you can set the rest of the tractor. You'll see reduced fuel economy, increased productivity, reduced labor costs, and that's what farmers are looking for today. Okay? Any questions or comments or thoughts?